So let's just get right into it. The internet, as you and I know it, well, it almost didn't happen. Seriously, it was heading straight for a brick wall, all because the system that lets our devices talk to each other was about to completely run out of addresses. I mean, picture it. The mid-90s. This was the general feeling. People in the know were convinced the internet was just fundamentally broken, that it was on the verge of total collapse because we were running out of room. And the whole panic? It all boiled down to one specific number. This one, 4.3 billion. That's it. That was the grand total of unique addresses available under the internet's original system, which we call IPv4. Now, that sounds like a huge number, right? But as the internet just exploded in popularity, it became terrifyingly obvious that this number wasn't a resource. It was a ticking time bomb. Now, to really get why this was a crisis, you have to understand the one fundamental rule of the early internet. Every single device that wanted to connect to the global network needed its very own, totally unique public IP address. No exceptions. You know, the easiest way to think about a public IP address is just like your cell phone number. It has to be one of a kind in the entire world. I mean, if you and I had the same phone number, the whole system would just fall apart, right? Well, the early internet worked exactly like that. And this is where the math starts to get, well, a little scary. Just think about your own home. You've got a laptop, a phone, a smart TV, maybe a gaming console. I mean, some households today have over 200 devices with an IP address. If every one of those needed a unique public number from that limited 4.3 billion pool, yeah, we would have run out of addresses before we even hit the year 2000. So with the internet basically facing certain doom, some brilliant engineers came up with this clever proposal called RFC 1918. Look, it wasn't meant to be a permanent fix, but it was a workaround so ingenious that it literally saved the day. Yeah, instead of trying to redesign the entire internet from the ground up, they just created a patch, a really big Band-Aid. They decided to take a few chunks of IP addresses and just set them aside. They called them private addresses. And the cool thing was, these could be reused by anyone, anywhere, on their own little local network. And here's the absolute key difference. Public IPs have to be unique, and they can talk to the whole world. Private IPs are not unique. In fact, your laptop and my laptop could have the exact same private IP right now, and they absolutely cannot talk directly to the internet. They're only for use inside a local network, like your Wi-Fi at home. So this is what they did. They basically carved out these ranges from the public pool and made them private. And that last one, the Class C range, the 192.168 block, I bet that looks pretty familiar. It's the most common range used by home routers all over the planet. Okay, so this brings up a huge question, right? If your computer has a private IP address that can't actually go on the internet, then how on earth are you streaming this right now? Well, that required a second piece of brilliant engineering. And that second piece of magic is performed by that little box with the blinking lights in the corner of your room, your router. The trick it pulls off is a process called network address translation, or NAT for short. You know, there's a fantastic analogy for this. Your router is basically Oprah. It's the master coordinator. Your internet service provider gives your router just one public IP address, and that's it. But your router, like Oprah, manages the whole show, making sure all your devices get to use that one single address to go online. So here's how this magic trick actually works. Your laptop, with its private IP, says, "Hey router, I want to see a website." The router takes that request, but it swaps out your private IP for its own public IP address, and then it sends it out to the internet. When the website responds, it sends the data back to the router's public IP. But the router is smart. It remembers that your laptop was the one who asked in the first place, so it forwards that data directly to your specific device. And it does this for every single device in your home, all at the same time. It's an amazing juggling act. And that right there is the magic of NAT. It's how dozens or even hundreds of devices in your house can all work on the internet using just one single, solitary public IP address. It was an incredible trick that massively extended the life of the original internet. But of course, there's a twist in the story. Even this amazing Band-Aid solution couldn't last forever. The internet's growth was just too fast, too explosive, and eventually we were going to need a real permanent solution. That's right. Even with private IPs and this magical NAT trick, the world officially exhausted the supply of new IPv4 addresses. The Band-Aid had finally ripped off. So it was time for the engineers to turn to the next generation. So say hello to IPv6, and as you can see, it is a completely different beast. It's way longer, it uses letters and numbers, and that allows for an astronomically larger number of possible addresses.
So how many more? Well, IPv4 had 2 to the 32nd power addresses. IPv6 has 2 to the 128th power. That is a number so ridiculously vast, we could get a unique public IPv6 address to every single atom on the surface of the Earth and still have addresses left over. We are not going to run out of these anytime soon.
Okay, so why should you care about this little history lesson? Because this whole story, the old Band-Aid and the new permanent fix, they're both running at the same time right now, and together they define your entire experience online. So let's just recap the big takeaways here. You've got private IPs and NAT, which are the clever hacks that let our home networks actually work. You've got IPv4, the old limited system we're still, believe it or not, transitioning away from. And then there's IPv6, the massive new system that's built for the future, providing a nearly limitless ocean of addresses for an internet that just keeps growing. You know, what started as this desperate temporary fix didn't just save the internet, it completely shaped it. It accidentally created the blueprint for how we all connect today, with our private home networks hidden behind one single public address. It really makes you wonder, doesn't it? What amazing new thing will be born not from some grand master plan, but from the next brilliant, necessary hack?